Hi everyone, I am Dr. P. R. K. Mary, working as a professor in the Department of IT at V.S.B. Engineering College, Karur. In this video, we discuss the concept of singly linked list. Before entering into this topic, first we understand what is list. List is a collection of elements. This list can be represented either in array form or in a linked list form. So the linked list contains three types. One is singly linked list, second one is doubly linked list, and third one is circular linked list. So now we discuss the concept of singly linked list. Singly linked list contains collection of nodes. Each node contains two parts. One is a data part and another one is a next part. So in this data, we contains we store the value, and this next part contains the address of the next node. So linked list contains the collection of nodes. Each node contains two parts. One is data and another one is next. In data part, we store the value, and the next part, we store the address of the next node. Now we create some nodes. So now I create the node 52. Then I create another node 34. Now this 34 and 52 are connected using the link pointer. Then I create one more node 45. This 45 and 34 are connected through the link pointer. So in this, each node contains some address. For example, this 45 address we assume at 1000, 34 address 2000, and 52 address 3000. Okay. So how these two nodes are connected? So 34 address. So this 34 address is 2000. This 2000 is stored in this node next pointer. And then how these two nodes are connected? This node addresses 3000. This 3000 is stored in this node next pointer, that is 34. Okay. So in this way, we connect one node with another node. So here after 52, there is no node. So it is specified as null. Okay. So this is an example for connecting the nodes in a linked list. So this linked list contains only one address pointer. So it is possible to move only in the forward direction. Okay. So a lot of operations are performed in this singly linked list. One is the creation, second one is insertion, third one is deletion, and the fourth one is display or traverse. Okay. So in insertion, it is possible to insert a node at the begin or at the end or at a specific position. In deletion also, it is possible to delete an element at begin or delete the element at the last position or delete at a specific position. So these are the operations are performed in the linked list. First we discuss how do we create a node. So node is created in Python programming using a class. Okay. So using this class, we create a node. Okay. So I create a class name is node. Okay. So this class name is node. In this class, I create one function that is called as a initialization function. So this initialization function contains two arguments. One is self and another one is a data. Okay. So when this init function is called, whenever you create an object, that time this init function is automatically called. In a object-oriented programming, whenever you create an object, the constructor is automatically called. In that way, in Python programming, this init function is automatically called. For example, I create an object. That object name is new node. Then I create the object using in this form. Data. Okay, so here I pass the data 15. That means this 15 is stored in this variable. and this self is referred as new node. That is the object reference. Okay. So in this new node, the data is assigned to that data field and this next pointer is assigned as none. Okay. So assume this is your new node. So in this new node contains two parts. One is data and another one is a next pointer. In this data, 15 is stored and the next pointer, none is stored. So this is the way for creating the node in singly linked list. Okay. So now I create a node, new node, that data is 48 and next pointer is none. So after creating the node, then you have to ensure whether this node is a first node or some node is already available. We want to join this node in already available list. Okay. So for that, we have to ensure that whether that head pointer is none or not. If the head, what do you mean by head? Linked list starting node is called as a head node. So you have to ensure that whether that head node is none or not. If it is none, that means there is no elements in the list. That means the list is empty. So what are the node you have created, that node is considered as a new node. Okay. Suppose if the elements are already available in the list. For example, we assume that it contains the two nodes. One is 40, then another one is 38, then none. Okay. So this list starting node is called as a head. Okay. So if head is none, that means there is no element in the list. So we have what are the node we have to create it, that is considered as a first node or head node. So in this situation, if head is not none, that means how do you connect this new node with already existing node? Okay. So this is our new node. Using that class, we assume that new node is created, that data is 30. So now we assign this new node next is equal to head. That means this head address is 1000. So that 1000 is stored in this position. That is, you connect this new node with that head node. Okay. So now this new list contains three elements. Now this is our first node. So that first node is called as a head node. So this is not a head. So we assign new node next equal to head. So new node next part, that is equal to head. That means 1000 is assigned to this new node next. Then next you assign this new node as a head. So this new node is also contains some address. For example, this address is 5000. So this 5000 is stored in the head node. That means the new node is considered as a first node. So in this way, we create the node in a singly linked list. Next, we discuss how to insert the node at the beginning. So insertion either you performed at the begin, end or at the specific position. Now we discuss how to insert the element at the first position. Okay. So in driver code, we call this function insert at begin with some argument. For example, we assume that argument is 40. So before creating any node, first you have to, before joining any node in the list, first you have to create a node. So how do you create a node? Using this node class. So this is the statement for creating the node. Okay. So now for this example, we assume that the node is created, the data is 40. Okay. This is our new node. Whenever we do the operation in singly linked list, first you have to ensure it whether this head pointer is none or not. What it means? whether the list is already available or not. If the list is already available, then this new node is joined at the first position. If the node list is not available, that means what are the node you have created, that is considered as a first node. So you have to ensure that whether head is none or not. Suppose if the head is none, that means the new node is considered as a head node. Then you return to the driver code. Okay. Suppose the list is contains some data. Elements is already available. Okay. So here this is our head node. Okay. So now you have to check whether this head is none or not. So in this example, head is not none. So automatically the control moved to the else part. In this else part, you have to connect this new node with already existing node. How do you connect it? So this head address is stored in this position. So the address is 2000 and this one is 3000. We assume it. Okay. So now this 2000 is stored in this position. How do you refer this 2000? This 2000 is a head part. Okay. So self head is assigned to new node next. That means this 2000 is assigned to this position. Now these two nodes are connected. After connecting this node, then you set this new node as a head node. So now you assign new node as head. That means this new node is considered as a head. Now our new list contains three nodes. One is 40, second one is 50 and third one is 45. So this is the code for how to insert the node at the beginning. Next, we move on to the next part, that is insert at end. So how do you insert an element at the last position? If it is the first position, it is easy to insert. If it is the last position, singly linked list contains only forward direction only. So not able to directly find out the last node. So you have to check one by one whether we reach the last node or not. How do you identify that particular node is the last node? If the node next pointer is none, that means that node is a last node. So first you have to traverse from first node to last node. Then you have to insert that node at the last position. Okay. So now we call this function insert at end. This insert at end contains two pointers. One is a self, that is self reference object. Then another one is a data. What are the data we want to insert into that particular node? That data is stored in that data variable. Okay. Now you create a node using this node class. So this is the line, this is a statement for creating the node. Okay. So now we assume that one node is created. Okay. So that node name is new node. That value is 50. Okay. Node is created. Whenever we do the operation, first you have to ensure it whether that node is a already some nodes are available or not. Okay, how do you ensure it? Using this head pointer. If the head pointer is not none, that means that already it contains some data elements. If the head is none means the list is empty. So you have to insert a new node, that is the first node. Okay, so using this statement you have to ensure it. If it is none, this new node as a head node. Okay, so now we assume so this list contains some data. For example, the data are so this is the list already available. We assume it. Okay. So now in insert at the end process, you have to search from first node to last node. So first node pointer is always as head. So if you change this head pointer, then it is not possible to identify which node as a first node. Okay. So if you want to do some traversing, then immediately you assign this head pointer to some temporary object. So here I assign this self head as a current node. Means this head as a current node. Okay, so using this pointer only, we traverse from one node to another node. Okay, so this while loop is used for traversing from one to another up to the end of the list. Okay, so in this while loop, we check whether the current node next. Current node next means this is current node, this is current node data part, and this one is current node next part. Current node next, it contains some values. Non-zero values are always true. So I already told you each node contains some address. Okay, so this 2000 is stored in this position. So now you check current node next. Current node next is nothing but 2000. So 2000 is a non-zero value. So it's automatically entered into the loop. So in that means this 48 contains some other node. Okay, so current node equal to current node next. Now we move from one node to another. This is current node. Now you have to check, you have to set this next node as a current node. Okay, so this is not a current node. Then again you check the condition. Current node next whether it is contains some values or not. So in this example, that current node next has none. That means it is a condition is false, so it automatically exit from that while loop. Now you have to assign. That means what? You have to identify the last node in the list. So after identifying the last node, what do you do? Just we have to create a link between the last node and the new node. So how do you create a link? This is current node. This is current node data. And what is this current node next? In this current node next, you assign this new node. That is the statement here. New node is assigned to the current node next. Now the last node is connected to the new node. In after inserting this new node, now this is our last node. So in this way, we have to insert a node at the last position. So I hope you understand how to create a nodes in a single linked list and how to insert an element in the element at the first position and how to insert the element at the last position. Next video will discuss how to insert an element at a specific position. Thank you.